Hello everyone, welcome back to my channel InfoSec Lab, and today we're going to continue our series of attacking and defending AWS service from TryHackMe. Now in today's room we're going over AWS VPC, which is another AWS service. So what is VPC? AWS Virtual Private Cloud, or VPC, is a software-defined network construct in AWS account. It logically separates your network traffic from network traffic of other AWS customers. Customers can define their silo ranges, connect their VPCs to their on-premise networks. AWS VPC are regional construct. You need to create a VPC in every region you want to deploy VPC-based workloads. By default, when a new AWS account is created, default VPCs are deployed in all the standard regions. Each of these VPCs uses the same 172.31.0.0/16 silo range. VPCs you create can use any silo range. You are not limited to RFC 1918 silo ranges. Okay, you can see your VPC on the VPC dashboard. The dashboard is helpful because it allows you to view VPC activity across all regions. VPCs have a VPC ID that begins with VPC dash. This VPC ID is unique across all AWS. VPC IDs used to be 8 characters long, but in 2018, AWS extended them to be 17 characters long. You can tell all the VPC by the short identifier. Network in a VPC is different from networking in on-premises environment. Because of the software-defined and multi-tenant nature of the public cloud, VPCs don't need anything like ARP to discover where the network devices are. ARP tables are visible to compatibility with the operating system's network stack, but typical attack techniques like ARP spoofing will not work in a VPC environment. If you haven't already done so, click on the orange cloud details button at the top right corner, and then so basically it tells you to generate the cloud environment and then use the credential provided to access the TryHackMe Cloud Sandbox. Go to the VPC console and have a look around. Not all resources are deployed in US 1. Okay. So VPC dashboard right here. View on the VPC, we have VPC room, Linux VPC, VPC. Okay, so we have 3 VPC in this regions. Global listing of all VPC. Note, for all the TryHackMe labs, we will be using US East, not Virginia, also known as US 1. Sample VPC ID in the VPC console, which is, if you select this one, this is the VPC ID that we talk about, VPC dash and then whatever it is. Okay, what is the silo range of the VPC named VPC room? To look for the silo range is right here. Copy, paste, submit. Yep. Accessing the environment, we'll skip this one. AZ, subnets, route tables, and oh my. VPCs consist of subnets, and each subnet exists only in one availability zones, or AZ. Subnets must use the silo ranges that are subset of the VPC silo range, and subnet silo ranges can overlap. Every VPC has a VPC router per AWS documentation. Your VPC has an implicit router, and you use the route tables to control where network traffic is directed. Each subnet in your VPC must be associated with a route table, which controls the routing for the subnet route table. You can explicitly associate a subnet with a particular route table. Otherwise, the subnet is implicitly associated with the main route table. A subnet can only be associated with one route table at a time, but you can associate multiple subnets with the same subnet route table. Confusing, right? Me too. Let's continue. VPCs have 2 special route destinations: the Internet Gateway (IGW) and Virtual Private Gateway (VGW). The Internet Gateway is the endpoint that acts as the border between the VPC and the Internet. The VGW is the endpoint that acts at the border between the VPC and the on-premise networks. You may hear the phrase public subnet or private subnet concerning VPC subnets. No AWS attribute explicitly define a subnet as a public or private subnet. The only thing that makes a subnet public is how the route table sends traffic to the internet. If a subnet has a direct route to the IGW, which is the internet gateway, it is public, and any resources that is in that subnet with a public IP address is accessible from the internet. If there's no public IP address or no route to the IGW or internet gateway, the subnet can be reasonably considered private. While a subnet could be configured to be automatically assigned to a public IP address to EC2 instances in the subnet without route to the IGW, the instance is not reachable from the internet. As an attacker, you could modify the route table to make the subnet route to the IGW and bypass some or all of the security controls. He who controls the IAM controls the network. Baron Harkonnen. Forgive me if I pronounce your name wrong. AWS offers something called Managed NAT Gateways. There are EC2 instances running by AWS provided. Excuse me. These are EC2 instances run by AWS that provide NAT capabilities to allow private subnet to access the internet. You would typically configure your private subnet to route to the 000 destination to the NAT gateway. Why you configure the route table of a public subnet to route the 000 destination to the internet gateway directly. From the above diagram, your route tables might look like this. Public route table 10.10.21 to local. Okay, where's the public route table? So AZA and AZB, where's AZA? This is AZA, availability zone A, and availability zone B. We have 10.121 to local. This is the VPC right here. Okay. In the public subnets, all internet-facing traffic goes to the IGW or internet gateway and the internet. For the two private subnets, traffic destined to the internet will go to the NAT gateway in the availability zones for resiliencies in case of an AZ failure. So these are subnet right here, and these are the VPN gateway. Okay. These are the public subnet because the traffic are directed to the internet gateway, which will be connected to the internet. So these are considered public, these two. Usually this one would be the main one, the primary one, and this one is going to be the secondary one for resiliencies as it's been mentioned. There is also a route to the on-prem corporate network 10.10.a/10.00/8 that points to the VGW. We'll discuss this how on-premise network talk to VPC in the future. Okay. So I guess this one is the one that will be connecting to the on-premise network. Okay. For the VPC in your account, the private subnets have a route to a fictional on-premise network. On-prem network via a VPN gateway. What is the side range of the fictional on-prem network? So first, let's look for the private subnets. This one, let's see the side. Okay, we have the resource map right here. This is the main VPC, and then we have 4 subnets. US is 1A and US is 1B. We have 3 route tables for this, and then 3 network connections. Let's see. This one VPC room public subnet. So this is public. We are looking for the private subnets. Okay. So skip this one, private subnet. Okay. We also have another private subnet right here. So looks like these 2 private subnets are the traffic are in this table, VPC room private route table. Let's take a look at it. a network connection. For routes, including local, choose subnets association. We have this one is connected to these two VPCE. Right, yeah. So let's take a look at the route tables. VPC room private route table. Let's take a look at route tables right here. Public route table, VPC private route table. Take a look at this one. This is the route table ID, domain, explicit subnet association. There are two subnets, yes. Destination, target right here. So we have these are what is the CIDR range of the fictional on-premise network? VPC. Again, if you look at this one, this is the VPN gateway, is the one that connects the private subnet to the on-premise network. So in this case, it shows the target VGW right here, meaning that the VPN gateway. So the CIDR range is going to be 172.18.0.0/16. Has to be correct. And NACL and security groups. Network access control lists, or NACLs, are one VPN, not VPN, are one VPC firewall construct AWS provides. NACLs apply to subnets. They are stateless in that both the initial inbound and connection and the return outbound traffic must be authorized. Network access control lists support either allow or deny actions, and the actions are evaluated in a specific order. Unlike IAM, an explicit deny does not override an explicit allow. Instead, rules are processed in order until a match is made. By default, network access control lists have a deny all rule. Here you can see how a network access control list is configured in the AWS console. In this specific case, the NACL prohibits all SSH traffic, then allows all other traffic. The final deny rule is the default from AWS. Right here we have network ACL 1 and for subnet 1 and network ACL for subnet 2. Okay, let's look at this one. Let's look for network ACLs right here, security. Click on this one. We have several network ACL. Let's see the subnet one. This is the network ACL for the private subnet. Second, inbound rule. The inbound rule is like allow all the traffic. Let's take a look at the public one. I'm not sure if this one is public. Wait, so many subnet. Which one should I look at? Okay, VPC. This VPC has 4 subnets. Side attacks, integrations. Now, if you're confused, not sure which network access control list to look at, you can go to the VPC right here, and then under here, the main network ACL. Click on this one. it will automatically text you to the corresponding ACL for this specific VPC. So let's go click on this one. We have this one with two subnets. Two subnets associated with this ACL. This is for the public subnet in 1A, and then this is for the public subnet in 1B. Inbound rules allow on traffic, outbound rules. Okay, subnet association. Okay, as we have stated earlier, where was it the one that prohibit on SSH? Let's see this one. Nothing. My VPC Linux. Okay, nothing. So I guess it was just an example provided for the reading material. So let's just continue. Because network access control lists are applied to an entire subnet, they have the high blast radius if misconfigured. For that reason, they're used less frequently than the other form of network access control, security groups. Sometimes a central network security team will configure network access control list for services they want to block with no exceptions. Security groups are attached to specific resources, such as an EC2 instance or RDS database. Security groups only support allow. Security groups are stateful and have different rule set for ingress and egress. Ingress is inbound traffic and egress for outbound traffic. Okay, as we can see right here, we have SMTP, server mail transfer protocol, and then we also have SSH, and we also have POP3. These are the rules. These are the rules within one security groups, and this is the outbound rules. Security groups are the primary way network level access is managed for resources. Security groups can reference either a CIDR range as a source or another security group ID. If a security group is referenced, any ENI with that security group attached is a valid source of traffic. The following table provided by AWS summarizes the differences between security groups and network access control lists. So security groups operates on the instance level, whereas network access control list operates on the subnet level. Security groups support allow rules only. Network access NACL supports allow and deny rules. Security group is stateful, return traffic is automatically allowed regardless of any rules. Whereas network NACL, you have to specify the rules for both inbound and outbound traffic. Just because the inbound is allowed doesn't mean that the outbound traffic is also allowed. In security group, we evaluate all the rules before deciding whether to allow traffic or not. In network access control list, we process rule in order, starting with the lowest number of rule when deciding whether to allow traffic. Security groups applies to an instance only if someone specifies the security group when launching the instance or associates the security group with the instance later on. Network access control list automatically applies to all instances in the subnets and is associated with. Therefore, it provides an additional layer of defense if the security groups are too permissive. So network ACL is like a bit more broader, general, whereas the security group is a little bit more specific, instance specific. Okay. What CIDR range in the security group VPC instance allow SSH? Okay, the thing is, I didn't see that. So VPC right here. Let's take a look at security groups. Oh, right here. Inbound, outbound rules. We have SSH. Okay, let's select this one. Also, what side range in the secure VPC instance allow SSH? This one. What port range is permitted in the private subnets from the on-prem network range? On-prem network. Again, we have to go back to private subnet right here, and then look for this one. Yeah, let's okay, security groups. Okay, this is confusing, a little bit confusing. Let's take a look at this one. The target is this one. We have resources side. Tags integrations. Okay, hold on. Let me go back. What port range is permitted to the private subnets from the on-premise network range? Oh, so we just look at the private subnet of the VPC. Subnet for public, private right here. Port range. I don't know, it's confusing. We have inbound rules. Entity inbound rules. Okay, where can I find it? Let's step one step back. PC subnet private network right here. It should be the same thing. This one should be the same thing. Available VPC route table. This is a route table, this is network. NACL the tags. What port range permitted for private network on-prem? Default to your group for most instant. Generic security groups for most instant. Nope. Allow SSH for try-me rooms. Okay. This one default security groups. Where was it? Is it this one? I'm not sure. Can I stop here? Where else can we find the answers? Subnet. Let's go to subnet. We have the VPC private, right? Let's go private. Let's go to this one. Right here. It's in the network NACL for the subnet 232443. My gosh. No, what? Don't include the space. Why? Why? Well, it is what it is. Moving on. What services are inside a VPC or outside a VPC? Okay. An essential concept in defending your AWS environment is knowing what resources reside inside a VPC and which ones are outside the VPC. EC2 instances, RDS databases, and big data things like Redshift are all examples of services that exist inside a VPC. Whereas S3 buckets, the AWS NoSQL database DynamoDB, exists outside of the VPC. Resources inside a VPC can be protected by NACLs and security groups, and you can prevent anyone from having direct access to them. Resources outside the VPC are protected only by IAM. Every resource inside the VPC has an Elastic Network Interface or ENI. ENIs are virtual network cards that are part of your VPC. ENIs can be attached to an instance, detached, and moved to another instance. Often, this is done to facilitate high availability failover. ENIs represent a DHCP release from the VPC's DHCP server. ENIs can also have a public IPv4 asterisk if configured as such. ENIs are tied to a specific subnet and can bridge an EC2 instance across two subnets, but only in the same availability zones. It is the ENI that security groups are attached to. You can get a holistic view of resources in a VPC by listing all the ENIs in an account. You can use the EC2 console or the AWS command line. Let's try that. AWS EC2 describe network interfaces. List the ENIs in your account. What is the description of ENI with the IP address 10.100.2.79? Where was it? Is it? Yeah, it's supposed to be secret, right? Yes. Not 100, not 2, not 29, 79. Okay, not this one. Nope, not this one. Okay, let me try another one. This is not working. Gonna use ChatGPT for help. Okay, let's try that. AWS easy to describe network interfaces, and then we use the filter flag. Names equals to private address, and then values is equal 10.100.2.79. Okay, we got it. Private IP address right here. What is the ENI listed in your account? Where is that? Oh, right here. What is the description? Where's the description? Hard-coded DHCP assignment. Yes, we made it. Okay, VPC wormholes, endpoints, and private links. For resources inside a VPC to talk to specific resources outside of the VPC, AWS has created two related services, VPC endpoints and AWS private link. These services allow a network or security team to limit or completely disable internet egress in a VPC. VPC endpoints were first introduced with the Amazon S3 service, so that machines in a private subnet won't need to leverage a NAT gateway to access S3. NAT gateways have a 1 GB per second network limitation and can be somewhat expensive. Before VPC endpoints, cloud architects were forced to put machines that require high bandwidth operations on the internet to access S3. VPC endpoints work with S3 and DynamoDB. VPC endpoints require a route to the VPC route table. The destination for those routes is an abstract representation of the service, known as the managed prefix list, rather than a specific CIDR range. AWS uses prefix lists to map AWS CIDR ranges into your VPC. These prefix lists help AWS manage its public IP addresses without requiring customers to change their VPC route tables or security groups. You can see the CIDR ranges for the different services with a command. Okay, let's try that. AWS easy to describe prefix lists. Okay. Here's the managed prefix list for the CloudFront AWS CDS service. You can see that AWS managed list IP address currently 44. Where? Okay, let's take a look at in the VPC, the AWS console. We have manage prefix lists right here. We have 11. Why is it 44? I don't know. Let's see this one. Okay. So that's the managed prefix list. VPC endpoints can leverage IAM to limit the use to specific S3 buckets or DynamoDB tables. However, as an attacker, you could add a VPC endpoint as a way to exfiltrate data from a VPC into an S3 bucket you control. Remember that trick when you get to your AWS Attack Capstone project? Not really. VPC private link is an ENI in your VPC tied to an AWS service or another AWS customer. It provides a way for AWS or its partners to offer services to AWS customers without requiring customers to allow traffic out to the internet. You can see here in the AWS console that a different private link services are available. Where? Okay, let me reopen. Okay, so I guess this option is to create private links. Endpoint settings. So these are the private links that we mentioned earlier, okay? As you see above, there are 177 available AWS services at this time of this screenshot. AWS charge 0.1 per endpoint per hour, so 1 cent per endpoint per hour. If you want to configure all 177 services for an entire month, you're looking for $1,274.40 bill. Okay, so these are the private links. Okay. Now we have 345, a lot more. You have a VPC endpoint in your VPC. What is the destination of the route table? Route table. What is destination in the route table? Is it private or public? This one? Yeah. What is the service name of the VPC endpoint? Is it this one? Nope. Prefix list name. EC2. Okay, that's an EC2. Nope, what's the hint? The answer can be found in VPC. Of course, duh. What is the service name for the VPC endpoint? Okay, let's start. Hold on. Let's go back. Endpoints. VPC endpoints. No. Alright. Okay, in this endpoint we'll have this one. Service names right here. Yep. Oh my gosh. Okay, moving on. DNS in a VPC. AWS has several services that can provide DNS inside your VPC. By default, instances in the VPC will use a Amazon provided DNS server. That DNS server is always at the base of the VPC IPv4 network range +2. So if your VPC CIDR is 192.168.15.0/24, that the default DNS server will be 192.168.15.2. The Amazon DNS server will resolve all the public DNS entries. You can also create a private Route 53 hosted zone and attach to the VPC. Route 53 is Amazon's hosted DNS service. Route 53 is highly available global service with advanced health check and failover capabilities. We'll discuss Route 53 in more details in a future module. For now, the critical concept is to know you can set up private DNS entries that the Amazon DNS provider will resolve for instances in your VPC. The VPC's DNS server can also be configured to answer requests from other networks, including on-premises networks, and to forward requests to on-premise DNS servers. DNS is another lateral movement path where compromise of the cloud can lead to the compromise of the corporate on-premises network. You can configure the Route 53 resolver DNS firewall and resolver query logging to CloudWatch logs as a protection measure. The DNS firewall allows you to configure which DNS domain the instances in your VPC and machines on-premise that leverage the Route 53 resolver are allowed to query or not allowed to query. The DNS firewall serves as a mitigation mechanism for DNS exfiltration attacks. DNS query logs will enable you to feed the DNS activity of your Route 53 resolver to your security information and event management SIEM for additional threat analysis. Many of these advanced Route 53 features have additional costs, and you should realize that when you incur charges on your security features. Your VPC is configured to send DNS logs to the log group VPC resolver logs. You can view the DNS entries from the CloudWatch logs console. You can search the entire log group in the upper right hand with the orange search log group box. What is the IP address of the task? Task 6 VPC room tryme.com. It's right here. One 169.254. Okay. VPC monitoring. Within a VPC, there are multiple ways of gathering security telemetry. VPC flow logs are like the cousin neck flow, in that they log the packet's headers but not the contents of the packet. The flow logs service can send the resulting logs to CloudWatch logs and an S3 bucket. The latter is cheaper and provides a multi-account, multi-regional approach by allowing enterprises to log to a central S3 bucket. Okay. Each field has a specific meaning as defined here. The first field is the flow log version, here number, which is always B2 if you're using the defaults. Next is the AWS account and the ENI identified. Okay. AWS account ENI. After that is the source and destination IP address, followed by the source and destination port. Okay, source IP address, destination IP address, source port, destination port. Okay. 6 represent the protocol number TCP. 21 is the number of packets, and 7010 is the number of bytes. Okay. The last four are the start and end times of the flow in Unix import time, the action accept or reject, and the log status, usually okay. Okay, so these are the timestamp, these are the action and the status. In 2019, AWS introduced VPC traffic mirroring. Traffic mirroring acts as a network tap on a per ENI basis and is useful for deep packet inspection. There are several limitations on where you can route all the mirror traffic. You need to have a layer 3 route from the source ENI to the traffic mirror target. DNS logs, part of the CloudWatch, as discussed in the previous task, provide telemetry around what queries machine in your VPC are marking. Amazon Guard Duty is a threat detection service. It leverages AWS threat intelligence and machine learning to detect threats. For network threat detection, Guard Duty uses VPC flow logs and DNS logs. Go to visit the CloudWatch and what's the name of the log group with the VPC flow logs? I don't know. The name of the log group with the VPC flow logs. Okay, is this one? Name? Is this the name? I assume yes. Okay, VPC interconnectivity. Whatever. AWS provides several ways to connect to VPCs. As an attacker, it's helpful to know the multiple ways to move from the cloud to on-premise networks, cloud to ground, and between different VPCs, cloud to cloud. There's also methods for end-user access via AWS Managed Service Client called Client VPN. Cloud to ground connectivity. For enterprise customers, AWS provides an interconnection service called Direct Connect. For companies with racks at specific data centers, AWS will literally run a fiber line from the cage to your router, giving you a dedicated link to the virtual VPN gateway in your VPC. Bandwidth of the link can range from 1 GB per second to 100 GB per second. Customers can share these fiber lines across multiple VPCs and multiple AWS accounts in the organizations. There's also the AWS site-to-site VPN for smaller organizations that don't need the level of bandwidth on latency direct connect provides. This service will initiate an IPsec Internet Protocol Security tunnel from AWS to your on-premise router or firewall. Excuse me. With AWS site-to-site VPN, you first configure a customer gateway which defines the endpoint AWS site-to-site VPN will connect to. You then must create a VPN connection that links the customer gateway with the virtual private gateway. Both Direct Connect and site-to-site VPN requires a route in the VPC routing table. The on-premise networks need to target the destinations of the VPC's virtual VPN gateway to route the traffic. From an attacker's perspective, this is a great way to pivot from the cloud to on-premise. From a defender perspective, you want to ensure that all site-to-site VPNs or direct connects terminate at the firewall and set least privilege firewall rules. From a compliance expert standpoint, it's important to note that while site-to-site VPNs encrypt traffic, since it's using IPsec, direct connect links are not encrypted as the traffic leaves your cage on its way to AWS cage. Okay. Cloud-to-cloud connectivity. Many companies adopt a multi-cloud strategy to separate their development and production environments and limit the blast radius across development teams. When different teams need to communicate with each other's VPCs, AWS provides two means. VPC peering is a direct one-to-one method of allowing VPC traffic to go from one VPC to another inside AWS network abstraction layer. Peer VPCs can reference each other's security groups. VPC peering works both across accounts and across regions. These features allow customers to replicate data to a disaster recovery setup that a development team should set up in different accounts and regions. VPC peering only works if the VPCs in question do not have overlapping CIDR ranges. VPC peering requires an entry in the VPC route table for the peer VPC CIDR range. The destination target for the route is the VPC peering endpoint. One essential concept related to VPC peering is that routing is not transitive within VPC peering. If VPC A has peered to VPC B and VPC B has peered to VPC C, there's no network path from a machine in VPC A to talk directly to an IP address in VPC C. The machine in VPC A would have to talk to a device in VPC B, which could then forward that to VPC C. The same transitive routing limitation applies to a VPN and direct connect connections. Alright, so just because A connects to B, B connects to C, doesn't mean that A also connects to C. If we want to do so, we have to actually manually configure the connection between these VPCs. AWS Transit Gateway was intended to solve the management of VPC connections by creating an inter-VPC router, rather than requiring a direct peer connection between each VPC that needs to pass the traffic. The Transit Gateway allows all of them to interconnect and supports direct connect and site-to-site VPN. The client VPN. One final VPC service attackers and defenders should be aware of is AWS Client VPN. Client VPN is best described as bypass the corporate VPN and access control as a service. It allows anyone with privileged access to an account to set up their own AWS managed open VPN service. Customers can configure client VPNs to use 3 different methods of authentication: shared certificates, AWS single sign-on offering, or AWS managed Microsoft Active Directory. In each case, the controls for multi-factor authentication, or MFA, identity management, and audit login are no longer under the control of the central IT, but are managed by the team running the AWS account. This makes the client VPN a potential security risk and compliance risk if not configured correctly. Can you find the IP address of the customer gateway for the VPN defined in your account? Yes, I can. Let's see. Do I have VPN? Yeah, right here, customer gateway. Customer gateway for VPN defined. Okay. Wait, what? Yeah, this one. VPN to on-premise. And this is the IP address. Whoops. What is the routing target prefix for the VPC peering connection? Routing prefix. So let's go to the route table. Oh, peering connections right here. There's no peering connections. What is the routing prefix for the VPC peering connection? There should be peering. What? My VPC. Let's look at the route table right here. Do I have any? Is this the one? That's the one. Okay, how do we do that? Include the dash in your answer. RGB? Is it? RGB dash? Nope. It's not in here. Let's try. Let's try Googling. Or ChatGPT. Yeah, let's try ChatGPT. Nope, doesn't help. Let's see if we can find anything on Google. VPC access to VPC using the longest prefix. How many prefixes are there? PCX, is it? Hopefully. It is. Alright, wrapped up. Now that we've learned about VPCs, you're ready for your next challenge. Finish this room and move on to applying what you've learned here in an exercise manipulating VPC exfiltrate data. Okay, so these are mostly the concepts of VPCs and multiple attack surfaces of VPC. This is a lot, I know, even I was confused about this too. But don't worry, everyone has his or her first time, and so do I. This is my very first time doing this room, so I'm just going to be continue repeating this room until I get familiar with all the concepts, and I mean at least get 50% of the 80% of the concepts, not 50%, that's too little. At least know what are available services related to VPC, where to look in the route tables, and what to look over there. Also, I think the most important thing is like you can tell the difference between network access control list versus the security groups. That's very important. And then what are the ways to connect VPCs? What are the ways to move from cloud to cloud or cloud to ground? And what are some ways for VPC to connect to each other or talk to each other, etc. So as long as we get the general concepts and get the general idea of how VPC services of how services within VPC work, then we should be okay with this room. All right. Thank you very much for watching me struggle in this video, and if you like it, please subscribe, and I'll see you next time. See ya. Bye.